All right, so today we're doing operations with radical expressions. So we're going to be simplifying more radicals, which is similar to what we did in 6.3. And then we're also going to be rationalizing the denominators. So we're going to be taking a few things further. Okay, so the first thing we're going to review is the product property. Okay, so the product property is if you have the nth root of two factors, sometimes they'll just look like a times b like this, sometimes there'll be multiplication in between. It's interchangeable with splitting it up into the nth root of a times the nth root of b, and it can go in either direction. Okay, remember that if n is even, okay, then a and b have to be greater than or equal to 0. Okay, so if it's an even root, you have to have both of those be positive. You can't just multiply them, two negatives to make a positive in terms of this rule. Okay, so we're going to do two examples for this. So the first one is if you have root 12 times root 3. So this is interchangeable, so if you have two roots multiplied together, you can change it into the root of 36, because that's 12 times 3, and the square root of 36 is 6. So you will be simplifying whenever you can. All right, and then why don't you try this one, the cube root of 24. So think about how you want to split that up. All right, so if it's the cube root, we should be looking for a perfect cube. What is the cube root in 24? Yep, so we can split it up into the cube root of 8 times the cube root of 3. Okay, which of course is going to simplify. So the cube root of 8 times the cube root of 3 will give you 2 cube root of 3. Okay, and then our quotient property is if you have the nth root of a over b, you can split that up into the nth root of a over the nth root of b. Okay, so for our first example, we have the square root of x to the 4th over 25. So let's use our rule. If we split that up, then we can simplify the square root of x to the 4th and the square root of 25. So we do that. Okay, so let's see if we remember some of these rules. If you have an exponent, what are we asking ourselves? So if it's x to the 4th, how can I simplify x to the 4th? What does the top simplify to? X squared, because the index is 2, so 2 goes into 4 2 times, and then we know the square root of 25 is 5. Okay? Now for number 2, this is a case where you can do this a few different ways. Okay, this is the cube root, and I know if I split it up into the top and the bottom, I would have to rationalize. That is something that we're going to talk about today. But you could also simplify to start, because what's 54 divided by 2? 27. And then x to the 4th divided by x is x cubed. 4 minus 1 would be 3. And then this is nice because they're both perfect cubes. The cube root of 27 is 3. The cube root of x cubed is x. Great. Okay, so we're going to be doing lots of simplifying today. So when it says to simplify each expression, you just want to keep these things in mind for the simplest form. These are taken right from your book, so some of them are going to need some notes with them so you understand what they're asking you for. The first one is the index n is as small as possible. That's because sometimes you can simplify whatever your index value is based on your exponents. The radicand contains no factors other than 1 that are nth powers of an integer or polynomial. When it says that are nth powers, they are talking about those perfect squares, cubes, and fourth roots. Okay, so that are nth powers, that just means that you can't have anything that's a perfect square, perfect cube, a fourth root, a fifth root, so etc. Okay, and to make sure that we do simplify those, we're going to be making lots of factor trees. You also want the radicand to contain no fractions. So whatever's underneath the radical can't be a fraction. Do you guys remember what the radicand is? Yes. It's under the radical. Yep. So whatever value is underneath the radical. Okay, and then no radicals are going to appear in the denominator. If they do, that's when we are going to rationalize the denominator. Okay. All right, so for the first examples, we're simplifying each expression. If you check any of your answers in the back of the book does not always assume that all variables are positive, so you'll see the absolute value, but we are going to assume whenever they ask us to simplify an expression that all of the variables are positive. Okay, so you can do that. We will assume all variables are positive for even roots. It only matters for the even roots because for odd roots you can have a negative underneath. Okay, and that means we are not going to have to worry about using the absolute value symbols. Okay, we're going to be doing very similar techniques to what we did in 6.3. Okay, so the first thing we have is the square root of 60, a cubed, b to the 22nd. Anytime we have a number, okay, we can factor tree. So for a, I want you to factor tree 60. I want you to simplify that part. And really, you can do all of a. And then if you want to give b and c a try, that is fine as well. So remember when you're doing the factor tree, it all depends on what your index is. Okay, so I like to always divide by 2 or 3 first. So if you cut this in half, 3 and 5, and then whatever the index number is, that is how many factors you're looking for. So if it's a square root, the index is 2. Okay, so if there's a group of 2, 2 goes on the outside, and then what will be left on the inside? 3 times 5. Okay, so you just multiply those two together. Okay, and then for the exponents, you just ask yourself, how many times does 2 go into 3? 2 goes into 3 one time with 1 left over. So that is what is left inside. 2 goes into 22 11 times. Okay, so that's going to be your final answer. So I'm just going to rewrite it with the spacing that I want. And then just make sure that your radical goes over everything that you want inside the radical. Okay, and then for B, your index is 4. So now you are looking for factors of 4. Well, if I do the factor tree with 4, it's just 2 and 2, right? There's no set of 4 that I can take out. So I know that the 4 is going to stay inside. And then 4 goes into 5 one time with 1 left over. 4 goes into 20 how many times? 5 times, so by to the 5th. Okay, and then don't forget if it's a 4th root here, it needs to be the 4th root here. And this is your final answer. Okay, now when you have a negative, it will be with a cube or 5th root. It has to be some type of odd root. And anytime you simplify with that, you are going to be taking out the negative. So if you start to do your factor tree, the 2 and 27, I'm hoping that now you'll recognize that this is a perfect cube. So this is like splitting negative 54 into the cube root of 2 times the cube root of 27. Okay, you could keep breaking that down until you have the 3's. Okay, but this is the same thing as the cube root of 2 times the cube root of negative 27. And what's the cube root of negative 27? Negative 3. So you want that negative to come on the outside, and then you're going to keep 2 in the cube root. Okay, and then will you do the x and the y? I'll give you a second to do that. And then we'll do part D together, because I want to show you something with that. All right, let's double check here. So you should have negative 3x squared y cubed times the cube root of 2y squared. 3 goes into 6 twice, none left over. 3 goes into 11 3 times. 3 times 3 is 9, which means you have 2 left over. Don't forget, you need to have that y to the 3rd and then also this cube root there. Okay. All right, now for part D, there's actually 2 different ways that you could do this after the first step. So the first thing we could do is we can split this up into the 4th root of 80 y to the 14th over the 4th root of 256 z to the 4th. Okay, you could have also reduced 80 over 256 to start. That would be another way that you could get to your final answer, but there's something special about 256. So to figure that out, you can always do your factor tree to see what happens, to see if you want to reduce or to see if something special happens here. So this is another no calculator unit, so we're going to use our factor tree. So we're cutting things in half. And as you're cutting things in half, I would take a number that we know, like 250. What's half of 250? 125, and then half of 6 is 3. So then you could add them together. Sometimes that's a little easier for your brain to do, like half of 120 and then half of 8, and then you put them together. Okay, and then when you get to 64, I would break this up into 8 and 8 because you know that 8 breaks down into what? Yep, 2, 2, 2. 2 times 2 times 2. Okay? So this is a 4th root. So anytime you have a group of 4 factors, 1 comes out. So you have a group of 4 2's. So a 2 would come out. You have another group of 4 2's. So another 2 comes out. And you just multiply them together. Okay? And then 4 goes into 4 how many times? Once, so it's 2 times 2z or 4z in the denominator. Okay, so this is why I wouldn't reduce it first, is because it is going to simplify. All right, and then we're going to do the factor tree for 80. So if we break down 80, again, I like to start with the 2's. It's really so that I can keep track easier of my group of 4. Because then I can just say, oh, yep, here's my group of 4. What do I have left over? The 5. So if I have 2 to the 4th, when I take the 4th root, a 2 comes on the outside. Okay, and then I have the 4th root of 5 is going to stay on the inside. And then I can simplify the y. So 4 goes into 14. How many times? 3 times. How many left over? 2. Okay, and then once you have this, you need to make sure that there's nothing else you can reduce. It's really simple to see here what can happen on the outside. If you have a 2 on top and 2 on the bottom, what happens? Yeah, they cancel. So you could cancel it at this step, or some of you might just jump to this. If you have 2 divided by 4, 2 goes into itself once, 2 goes into 4 twice. So then you have y to the 3rd times the 4th root of 5y squared divided by 2z. I'll always make my z's with the line through them so you can distinguish them from the 2's. And really, so I can distinguish them from the 2's. Right? So I don't accidentally try to multiply 3 together. Okay, and then what if these were switched? What if it was 4 over 2? Yeah, it'd just be 2, and where would the 2 go? Yep, on the top. Okay, so you can always reduce that. All right, feel pretty familiar so far? All right, then for our next example, you're going to be simplifying with 2 radicals multiplied together. So just like we've been talking about, you can simplify outside with outside and inside the radical with inside the radical. Same thing happens when you multiply. So you can multiply the 6 times the 4 because they're both on the outside to get 24. And then the square root, you would do 3 times 24 to get 72. Okay, and we know there are 24 hours in a day. Do you guys know in 3 days there'll be 72 hours? So things like that can help you multiply in your head. Okay, what's a times a? A squared, b times b cubed, b to the 4th. Okay, and now we have to simplify. Okay, and again, we're doing this without a calculator. So why don't you go ahead and simplify that? I'll give you a minute to try that. And then you can also try these. If you finish that quickly. Okay, and then when you're doing your factor tree, some of you might notice a perfect square right away because this is a square root, right? So if you split this up into 2 and 36, well, don't we know the square root of 36? Yep, so this is 6 root 2. Okay, so you can multiply the 24 by the 6 on the outside. We can leave it there for now if you want. The 2 is going to stay on the inside, and then we can simplify the A and the B. Okay, so for A, again, remember, it's all about the index number. If it's a square root, the index is 2. 2 goes into itself once, 2 goes into 4 twice. Okay, and then if you're multiplying 24 times 6, it might be easier to just do 20 times 6, which is 120. 4 times 6, which was 24. Okay, so you have 144 AB squared, square root of 2. That is your final answer. Okay, so then B is very similar, where whatever's on the outside, that's what gets multiplied together. So you have the 15. In the square root, you have 2 times 7, which is 14. X times x squared is x cubed. And then you have y cubed. Okay, so let's simplify what we can from there. Numbers and the variables. And you don't necessarily have to do the factor tree for that, but you can, so you can see whether or not there's something else you can simplify. So like 14 breaks down into 2 and 7, right? So there's nothing that I can take out of there, so I know it has to stay inside. Okay, 2 goes into 3 once with 1 left over. That is the same exponent, so the same thing happens. So you have 15xy times the square root of 14xy. All right, so now we're going to revisit the division and rationalizing. And there are several different ways that you guys can do these. For the first one, I am going to show you the 2 different ways, and then from there, you guys can choose what you would like to do. If you have a denominator that is a square root, okay, then you can multiply the denominator by the exact same thing. The reason why is because if it's a square root, all you need is 2. So if you multiply something by itself, that is where the 2 comes from. So if you had 4, bless you, you had 4 over the square root of 7x. When you're deciding what to multiply by, in this case, b is your 7x. Okay, you are going to multiply the top and the bottom by the square root of 7x. The reason why is because that makes the square root of 7x squared. And what happens when you take the square root of something that's squared? Yeah, you just get what's left inside. Those cancel each other out. They're inverses. And so you're just left with the 7x there. Okay, on top, you're just going to multiply 4 times the square root of 7x. Why can't I cancel anything out here? Yep, one's under the radical, one's not. Okay, so I have to do what's inside the radical before I could do any division. Okay, so this would be your final. And just bring that over. Okay, now they're not always square roots. Sometimes they're cube roots, fourth roots, fifth roots. Okay, and sometimes they have an exponential power. So sometimes the exponent is 1, sometimes it's 2. Okay, this is a general form. All right, so moving along. When you are trying to figure out what to multiply by, in the past, I just gave you something to think about. You can use this as a formula, but I think some of you are so good at understanding it, you won't necessarily need to use that formula, but I do want to show you where it comes from and how you can apply that. So you can always multiply by the nth root of the difference between the root and the power. Okay, so this is the nth root of b to the n minus x. Okay, and then this is how we use it. So let's say you have 3 divided by the 5th root of 2. Okay, in this case, your n is what? 5. Your b is 2. And then do you guys know what your x is? 1, because you can't see it, right? So if you're trying to figure out what to multiply by, you can just multiply by 2 to the power of 5 minus 1, which is what? 4. Okay, but remember we've already done some practice with this, and what I talked to you about is, oh, if it's the 5th root, if you already have 1, how many more do you need to get to 5? So if you multiply 2 to the 4th times 2, that's going to give you the 5th root of 2 to the 5th. So we want 5 2's in order for those to cancel out. And what is 2 to the 4th? 16. So this is 3 times the 5th root of 16. Okay? And again, I'm just drawing the arrow there so we don't have to rewrite that again. All right, so if you feel like you're really good at understanding, oh, I have 1 there, I need 4 more to get to 5, you won't even necessarily think about that, but it's just another tool that you have if you are not sure what to multiply by. Okay, so example 6 is simplifying. And like I said, there's going to be 2 methods you can use to solve. So I'm going to show you both methods, and then I'm going to let you choose which one you want to use. Okay, so for these, we're always going to split this up here. There's nothing I could simplify anyway for this type of problem. Okay, so method 1 is generally what I gravitate towards. I think a lot of you might be the same, where you simplify first. Okay, so you can either rationalize first or you can simplify first. I think a lot of you are going to like to simplify first. So if we do that, okay, on the top, I can't do anything with the 5. My index is 2. Okay, so 2 goes into 5 how many times? 2 with how many left over? 1. Okay, so I simplify the top into a squared times the square root of 5a. Okay, will you go ahead and simplify the bottom if you haven't already? Okay, so then on the bottom, how many times does 2 go into 13? 6, so you got b to the 6 times the square root of b. So in this case, you have the square root. So the rule is you're going to multiply by that same radical. Okay, so we're going to multiply the top and the bottom by the square root of b. Just so happens to actually be b. And I feel like I say this all the time, so I'll say it again. The only reason you can do this, that you can multiply by something over itself, is because it's equivalent to what? 1. So you're not changing the value of it. Okay, so when you do that, in the numerator, you're going to have a squared times the square root of 5ab. So multiply the radical by the radical. We just did that earlier. Here, when you multiply, you have b to the 6 times, and what's going to happen when you multiply the square root of b times the square root of b? You're going to get b. What's b to the 6 times b? B to the 7. Good. So this is going to be your final answer. Again, nothing to simplify because nothing is outside of the radical for us to simplify. Okay, and then method 2 is where you rationalize first. Okay, so we simplified and then rationalized, but your other method is to rationalize first. Okay, so we would stick with the 5a to the 5th over the square root of b to the 13th. And then we have to figure out what to multiply by. Okay, so because the index is 2, what we would want to do is multiply by the square root of b. You could also multiply by the square root of b to the 13th. You could do that as well. And then you would have to simplify. So that would give you the square root of b to the 14th on the bottom. And the square root of b to the 14th is what? B to the 7th. Okay, and then you would multiply these together. So it would be 5a to the 5th b, and then you would simplify. So you would say, okay, 5 has to stay inside the radical. 2 goes into 5 twice with 1 left over, and then b would stay in there as well. You'd end up with the same thing. Okay, so I want you to try part B, and you can choose whichever method you would like. So you can choose to simplify first, or you can do rationalizing first, whichever you're most comfortable with. Okay, so it looks like most of us did the simplifying first. Okay, so if you're simplifying the root 20, most of you are going to know that the perfect square that goes in 20 is 4, right? So you can simplify that to 2 root 5 right away. Okay, so 2 comes on the outside, 5 stays on the inside. Square root of 4 is 2, 5 can't be simplified. Okay, and then you're going to keep your x inside, nothing else to simplify there. Okay, and then on the denominator, 3 is going to stay on the inside. Your index is 2. 2 goes into 5 twice with 1 left over. So when you're deciding what to multiply by, anytime it's a square root, you always multiply by the same root. So you have to multiply by the 3 and the y. Okay? So when you do that, in the numerator, you get 2 times the square root of 15xy. In the denominator, you have y squared times 3y. Multiplying something by itself is going to give you that radicand. And so your final answer is 2 square root of 15xy divided by 3y cubed. Okay, and again, nothing else to simplify. You can only simplify what's outside with what's outside there. All right, so for part C, we have the 4th root of x cubed over the 4th root of 5b squared. So remember, we're trying to get to a power that is equal to the index. Okay, your index number is 4. So there's a couple different ways you can think about what you're multiplying. I always start by making sure I have the right index number there. And then if you want to use this, then think of this as 5 with an exponent of 1. What's 4 minus 1? 3. So you have to multiply by 5 cubed. You can do the same thing with the b. 4 minus 2 is 2. So you can multiply by the 4th root of 5 to the 3rd times b squared. Okay, so you do that on the top and on the bottom. Okay, and then again, the reason why you are doing that is so that when you multiply these, you have the 4th root of 5 to the 4th times b to the 4th. That's what allows us to get that common, not a common denominator, but that's what allows us to get that denominator without the radical. The 4 and the 4 cancel, and you're left with 5. The 4 and the 4 cancel, and you are left with b. Okay, and then in the numerator, we do have to evaluate 5 to the 3rd, which is what? 125. Okay, and then we have x cubed and b squared. Generally, we'll write these in numerical order. Okay, don't stress out if you wrote the x cubed first. You don't have to rewrite that. Okay, and it's always good to just double check to make sure there aren't any perfect values. But remember, 125 factors to 5 times 5 times 5. Can't break that down anymore. Okay, so you can't break down 125. All right, so I'm going to give you the rest of the time to work on your homework that is due tomorrow.